This will be our third and final video for section 10.5. Last video we looked at intersecting lines and circles. If you have two lines that intersect on a circle, remember there's three places where those lines can intersect. They could intersect on the circle, and if that happens, we're going to use theorem 10.7, which tells you the measure of an inscribed angle, like that blue one, is half of the measure of its intercepted arc, like that orange one. If your two lines intersect inside the circle, you could use theorem 10.12, which tells you this blue arc and this red arc can be averaged to find that green angle right there. And notice how its vertical angle is the same thing. And vice versa, if you knew that green angle, you could find one of the two measures of the arcs. Well, what if you have your two lines and they intersect outside the circle? How would you find arc measures or angle measures then? Well, that's what theorem 10.13 is for. So we're going to look at theorem 10.13 in this video. So theorem 10.13 is the angles outside the circle theorem. Make sure you mark that in your packet. If you have a tangent and a secant, like you do in that first example, I'll put a green star there, that's your tangent and your secant. Or if you have two tangents, like the second example, I'll use maybe a different color star, maybe a red star, like that guy. Those are two tangents that intersect outside the circle. Or if you have two secants that intersect outside the circle, I'll use a blue star. Those are two secants that are making an angle that's outside the circle. How are you going to figure out angle measures or arc measures? Well, the measure of the angle formed is actually half of the difference of the measures of the intercepted arcs. So in each one of these situations, whether it's angle 1, angle 2, or angle 3, where you have two tangents, two secants, or one of each, you're going to take those arcs. So we're going to go with this blue arc right here, and we're going to subtract from it the measure of the green arc. And then we're going to divide that by 2, and that will give you the measure of that angle 1. Okay? So you're going to do that for all of these. You're going to do blue arc minus green arc divided by 2, or times 1/2, same thing. Blue arc minus green arc times 1/2. Okay, now there's a couple things that I need to point out to you. When you have the two tangents, like in this red star example, notice how the two arcs, the blue and the green, they add up to 360. There's no other arcs in the picture. If you go back to the diagram to the left there, notice how you still have this arc over here. Okay? Look at the third example. You have two different arcs there. So sometimes they give you that information instead of the information that you actually want. Okay, another thing that's going to get you into trouble, since you're subtracting arcs, you better make sure that you're subtracting the little arc from the big arc. It's got to be big minus little, not little minus big. Okay, let's try some. There's an angle that's formed by two segments that are intersecting outside of a circle. We are going to use theorem 10.13 here. We have a tangent and we have a secant. And you handle this the same way if they were both secants or both tangents. You have this blue arc, which is our bigger arc. Then you have this green arc, which is our smaller arc. Remember what that theorem says. The theorem says to find the difference of those arc measures. So we're going to subtract 76 from 178. And we're going to take half of that. So you can divide by 2 or multiply by 1/2. It's totally up to you. But 178 minus 76 is 102, and then half of 102 is going to give you 51. That's what x is, 51. We're going to skip ahead to this slide, and we're going to do that middle problem first before we jump back to that real-world example. We have a tangent and a secant. Oh, I'm sorry, excuse me. These are actually both secants. You're still going to use theorem 1013 because those secants are intersecting outside the circle. We'll use the same color concept. That big arc minus that little green arc, half of that has to be 30. Okay, so we'll say that again and we'll write this down as we go. You need to take the big arc and subtract the little arc. And half of that would equal your angle, which is 30. Now you want to get that big arc, the blue one, A, by itself. So you're going to multiply by 2. And then you're going to add 44. So it looks like that big arc has a measure of 104. And you can check yourself. Let's do blue minus green. 104 minus 44. That gives you 60. What's half of 60? It's that 30. Okay? So that's a good place where you can use theorem 1013. Okay, another place would be in a real-world situation like this science problem. We have this diagram of Earth. The northern lights are bright flashes of colored light that occur between 50 and 200 miles above Earth. Suppose a flash occurs 150 miles above Earth. What is the measure of arc BD? That's the portion of Earth from which the flash is visible. They tell you that Earth's radius is about 4,000 miles. Okay, so what are we looking for here? We want to find the measure of that magenta arc. And we can do that with the information given. Notice how the radius of Earth is 4,000. I'll make that red segment. And then I'll use a green segment here. Segment AC is green. That's 4,150 miles. And how did I know that? Well, I'll use blue if you can see that. That's your 150 miles above Earth. So that blue segment plus your radius that's 4,000 gives you that 4,150. Okay, now that point C is formed by two tangents, and you can tell it's formed by two tangents because there's right angles there. And that's important because that gives you right triangles. I'm really cramped for space here. I'm going to do my best here, guys. In this right triangle, that's 4,000, and your hypotenuse is 4,150. Now, you know everything there is to know about right triangles. What you would really like to know is, remember, the end game here is what's the measure of that magenta arc? Well, if you had the measure of this green highlighted central angle, then you could figure out the measure of that arc. Okay? Now that green central angle is 2 times the measure of that angle where that red dot is. And that red dot lives right here. Okay, so maybe I'll just call it x. How could we find x? Would we use sine, cosine, or tangent? Okay, that 4,000, that's our adjacent leg, and the 4,150 is our hypotenuse. So we're going to use cosine. So I'll write this out. I'm going to try to be careful because I know I have more work to do. Cosine of x equals my adjacent over my hypotenuse. To get x by itself, you got to use inverse cosine. Just be careful, make sure you're in degree mode. Type this in your calculator. Inverse cosine of 4,000 divided by 4,150. And that's going to give me a decimal, obviously. So our answer is approximately 15.45. That's not exact. Now, if that's what x is, remember that's this angle right here. This angle over here is going to be the same. So really, 2x is the measure of that central angle. So if you still have that exact answer in your calculator, multiply it by 2, and that answer that you see right there, that is the measure of the central angle. And remember, the central angle is the same as the measure of that arc right there, arc BD, and that's what you want. Okay, so that 2x, oh no, that 2x is 30.90 degrees. You got something similar happening in this last example. I'm going to take a second and I'm going to erase some stuff just so I have some room to work. This is kind of like that Northern Lights problem that we just did. You want to find x. We'll make that this magenta arc. Okay, now we have this two tangent concept going, just like the Earth problem that we just did. Remember that hint I gave you? When you have two tangents, you only have two arcs in the circle. So if you can find the measure of the green arc, you can find the measure of the magenta arc by just subtracting from 360, if that makes sense. Okay. So in this triangle that we have going here, our circle, we have a radius of 3. Notice how that red segment there is also 3. So we have a very familiar looking right triangle. We have a 3, something, and 5 triangle. 3 plus 2 being 5, that would be your hypotenuse. Okay, so this guy's obviously 4. Remember what we're looking for. We would like to find this angle where that arc is. Okay, so we'll call that x. How are we going to find x? We're going to use cosine. We're going to do, hopefully you're cool with skipping a step here, inverse cosine of 3/5. That's the measure of that x. So make sure you type that in correctly. Inverse cosine 3/5 gives me about 53.13 degrees. And again, that's not exact. Now, this angle over here is the same as that. So you could just take that same answer in your calculator times 2, and that's going to give you the 106.26. So we'll call that 2x. Oh, I'm writing down the wrong number here for some reason. Let's try that again. Should be 106.26. So that's the measure of the central angle. That's also the measure of the green arc. So if you want the measure of the magenta arc, oh, god dang it. The magenta arc is called x, and I've been using x this whole time. Dang, that's not a good idea. So switch all your x's to y's. Just use a different variable. Sorry about that. Okay, so let's do 360, and let's subtract away that 106.26 that you still have in your calculator. Remember, subtract the exact answer, not the rounded answer. And that'll give you the measure of the magenta arc, which is what they're calling x. And that'll give you 253 point, we'll round now, 74.